All right, you guys, I'll try to get through this really quickly. Sorry we didn't have enough time with our shortened class period today. So our fourth and final way to find slope is in word problems. Now, I'm not saying every single word problem is going to provide you with the slope, because it's not. But if you are provided with the slope, then you're probably going to see words like per, each, and every. Okay, because these are unit rate words, right? So like if I have a job and I make $20 per hour, $20 each hour, $20 every hour, right? Those words are giving us rates, and that's exactly what slope is, right? It's a rate of change. All right, so when you're reading a word problem, you want to look for these words. And if you don't see these words or anything that implies a rate of change in any way, shape, or form, then that means you're not being given the slope. But you'll probably be given enough information to find it in a different way, which we'll see that here in just a few minutes. So on number one, it says a jeweler charges a flat fee of $50 for a bracelet. For any charms you want to add, he charges an additional $22 per charm. Right, and there's our slope, right? Because there's our keyword per. So I know that our slope is talking about $22 per, or for every one charm. Now, you're not really going to write your answer like that necessarily, right? I obviously want you to take out the units of measure. We're not going to write dollar signs and charms in our slope, right? So we're just going to leave this as 22 over 1, or of course you can just write it as 22. You don't have to leave it as a fraction if you don't want to. So I'll take either one of those answers. Now, before we move on, the whole point, and we kind of started doing this in Unit 2, talking about those X and Y variables. If we were graphing this situation, the very first thing that you would be responsible for is labeling your X and Y axis and figuring out which variable is what. So remember, variables are things that will change through the course of this problem. Now, the awesome thing about finding slope is, remember, slope is the change in the y's over the change in the x's. So the reason why I wrote it like this with the units of measure in there is because the units are telling me what the x and y variables are. So if my numerator is $22, that's because my y variable is dollars. And if my denominator is every one charm, then that means my x variable is the number of charms, right? These are the two things that are going to vary throughout the problem, right? I add another charm, more money. Add another charm, more money, right? And so that's really the great thing about being able to identify your slope, is not only did you find the rate of change, but you also found what the two different variables are, so you can graph the scenario, right? And that's kind of where we're going to be going next week. All right, so let's move on to this next one. At the store, apples are $2 each. There it is, right there. There's our keyword, right? So apples are $2 each. Now, instead of saying $2 each apple, right, they kind of wrote it in reverse, which is totally fine. That still just means that it's $2 per one apple, which again, you're not going to write your actual slope like that. I'm just doing that so we can see what the variables are, right? So you're going to write 2 to 1 or just 2 for your slope, right? But I know, again, you don't have to do this off to the side, but I'm going to, because I think it's really good practice, right? To recognize, oh, well, if my slope is y's over x's, then again, that means my y is money and my x's are number of apples. All right, so again, slope tells you lots and lots of things, not just the rate of change. All right, next up, at top speed, a cheetah can run 110 feet every second. Well, there's the word every. I like seeing that. So 110 feet every second. All right, I'm going to write that down. 110 feet every 1 second. So, of course, that means our slope is just 110 over 1. Like, take the units out. Don't write units in math problems, right? But again, I know I sound like a broken record, right? But that's the reason why I like writing the units in there initially, is because now I know that my y variable is feet and my x variable is seconds, or time in seconds. right? So we've got distance and time, feet and seconds, right? And I know exactly which axis to put which variable since I know slope is y's over x's. All right, last one here. The Smith family found a great airline deal for $150 per person. Yay. All right, there's that keyword per, right? Per, each, every, right? So we know that our slope is $150 for every one person. Take out the units of measure, and that would just be 150 over 1. Or 150. And again, you don't have to do this, but I'm going to go ahead and label a lovely little x and y axis, right? I automatically know my y axis is money and my x axis is number of people. Okay. The only thing I kind of regret with these examples is there's not a single one that is negative, right? So obviously if any of these questions said like, like let's say number 3 was talking about an airplane landing, right? And it was decreasing its altitude by 110 feet every second. Oh, that would be really scary. But then that would be a negative, right? So you always want to pay attention to, are you increasing or decreasing? Okay. So yeah, so we'll talk more about that though next week. All right, this 5th one, I've labeled it kind of a challenge question because if you read this prompt, it says, including tax, the total cost of 3 cookies is $5.50, and the total cost of 8 cookies is $12.75. Well, did you notice the word each, every, or per anywhere in there? Because I certainly didn't. And I obviously, if I'm looking for the unit rate or the rate of change for cookies, they would have to tell me what the cost was per cookie. And they don't. They tell me what the cost is for 3 cookies or for 8 cookies. So what we're going to do is we have to find the slope in a different manner. Well, if they tell you 3 cookies costs $5.50, what they're really telling you is the point 3 comma 550, because the total money would be the y variable, because the amount you spend depends on how many cookies you buy, right? So cookies would be the x and 550 or the money would be the y. And then they're telling you that 8 cookies is $12.75. Well, if I plot that on a graph, then that of course is going to be the point 8 comma 12.75. And so now, instead of actually just spoon feeding us the slope, they have given us 2 points of information on this linear function. And what can I do with 2 points? You know it. We're going to do the slope formula, right? So we're going to do our change in y over change in x by subtracting. So we're right back to the problems we did earlier in the notes. So here we go. I'm going to subtract. I'm going to do 1275 minus 550 because that's going to tell me how the cost is changing. And then on the denominator, I'm going to do 8 cookies minus 3 cookies. Right, and so we're going to do that subtraction, or you can put that all in your calculator in one fell swoop, but I'm just going to do it one step at a time. So that's giving me 725 and then over 5, which basically is telling me that overall it costs $7.25 for 5 cookies. I'm going to go ahead and do that division, and that's giving me $1.45 over 1. Or you can just write $1.45. Again, very similar to what we were just saying above. Put equals M. Sorry about that. There we go. Right, and of course, by finding that slope, right, we now know that we can interpret this as $1.45 per cookie. Right, and that is what that is telling us. And we didn't know that going in, right? Because there's obviously some sort of initial cost happening here. Because if we just divide 550 by 3, we don't get $1.45, right? And so maybe they're making us pay extra for the little box it comes in or something like that. But anyway, we're not going to worry about that today. But just finding that slope using our slope formula, okay? All right, if you turn to the very last page, this is doing slope in reverse. And what I mean by that is normally we're given 2 points, like right here on this problem that we just did. Normally we're given 2 points and we're asked to find slope. On this problem though, they're telling us the slope, right? It says right here, the slope between 2 points is 3. Now keep in mind what that means. Slope is always a fraction, always. So if it's not a fraction, right, you're going to make it a fraction by putting it over 1 so you can see that rise over run. So I don't know where this line is on this graph, but I do know I'm rising 3 and running 1 to get from one point to the next. Okay, so that's what I know so far. Then the other thing I know is that this graph is passing through the point 1, negative 4. Oh, that's pretty handy. So I'm going to plot this. All right, I'm going to plot that point. Let's do that. 1, negative 4. 1, negative 4. So that's right there. Then they're asking us, then what point is this? So this point must also be on the line, but it has a y value of 8. Okay, I'm just going to number this really quick. 1, 2, 3, 4, 5, 6, 7, 8. So this is a y value of 8. And they want to know what point on this line that has all these other characteristics, what point has a y value of 8 and what is the x value of that point, right? And so that is what we are trying to determine. Okay, well, let's see. I've already plotted my point 1, negative 4. And now I'm going to plot the slope because I know this line has a slope of up 3 over 1. So from this point, I'm going to go up 3 over 1. I am not even close to this y value of 8 yet, so I'm going to keep going. Up 3 over 1. Up 3 over 1. Up 3 over 1. Looky there. All right, so now I have a y value of 8 at that point. So I just really need to know what is the x value at that point. 1, 2, 3, 4. It looks like it's an x value of 5, which makes sense because this is the point 5, 8. And I know it lies on the same line that has that slope of 3. So my answer is x equals 5. And there you have it. So using a graph to solve for a missing coordinate, knowing your slope, right? So kind of doing all of that work backwards. Okay, so I'm really hoping that makes sense. There is another way you can do this problem without the assistance of a graph, and that's to do the entire thing algebraically as opposed to graphically. Now, most people are going to be a lot more comfortable graphically, so we will be providing you a graph on every single question like this that we ask you. But if I am going to show you the algebraic way to go about it, if you ever want to use this way. So I'm just going to show you this really quick. Again, if you don't want to do anything I'm doing right here in this space, then that's totally fine, okay? So we're going to do the same thing. You're given the slope, it's negative 4/5, and we have 2 points, and we're missing an x value again. Okay, so solving it algebraically instead of graphically, what I'm going to do is I'm going to use my slope formula because that's basically all the information I have going on here is I've got 2 y's, 2 x's, and a slope. So I'm going to use my slope formula, and I'm going to plug everything in where it goes. So for example, they told me the slope, so it's going to go here, right? My y2 is going to go here. My y1, I'm just going to color code this really quick, is going to go here. And then my x2, which is 7, is going to go here. And which color have I not used? Purple. And then the x that I'm solving for, he's going to go right here, right? So I'm taking all 5 pieces of information that were given to me, and I'm going to simply plug it into my slope formula. So here we go. So my slope is negative 4/5. Oops, sorry, there we go. And I'm going to put that negative with the top number because when it's out front like that, you need to assign it to either the top or the bottom number. It doesn't matter. I always give mine to the top though. And then let's see, I'm going to do the green minus the blue. So y minus y. So I'm going to do negative 2 minus 6. And then I'm going to do x minus x, which is going to be 7 minus x. All right, now I'm going to simplify this because it's the only part of this equation here that I can actually do anything with. So negative 4 is to 5. Let's see, negative 2 minus 6 is going to give me negative 8, and then 7 minus x. Okay. So if you recall from middle school, right, this is called a proportion. When you have two fractions equal to one another, it's a proportion. Now you can kind of use your common logic here because the numbers are relatively friendly, but they're not always going to be super friendly numbers. So we're going to solve it as if we couldn't tell what these numbers are supposed to be. Okay. So remember from middle school, when you're solving a proportion, you cross multiply. Your teacher might have called it like the butterfly method or something like that, right? It's when you do these two and you multiply them together, and then you do these two and multiply them together, and it kind of looks like a butterfly, right? So what I'm going to do, it doesn't matter which way you cross first. I'm going to go this way. But what you do have to remember is that 7 minus x is a binomial. So when I multiply by negative 4, I'm going to have to make sure I multiply. I'm just going to go ahead and write it all out like this first. So it's going to be negative 4 times 7 minus x. And then when I multiply this way, I'm going to get 5 times negative 8. And again, it doesn't matter which one you do first or what's on the left or the right. I've just chosen to go in this order, right? But the equal sign just comes right down in the middle after you do your cross product. And then this is just a normal everyday algebra equation that you would solve like from unit 1. Right, so we clearly need to distribute the negative 4. So it's going to give me negative 28 plus 4x, and then 5 times negative 8 is going to give me negative 40. Well, this is just a basic two-step algebra equation where we're solving for x, right? So we need to obviously get that plus 28 over here to this side. So that's going to give us 4x equals negative 12. And then when we divide by 3, let me scooch all this up. I very much feel like it's very much run out of room here. Sorry. When we divide by 4 on both sides, we're going to get negative 3. Okay, and then that is our answer, right? That would be the x value of that given coordinate, right? After I plugged all that in and solved it algebraically. Now, is that a lot more work than just plotting it on a graph? Absolutely, it is, right? Which is why we will typically always give you a graph to use so that you can do it in a little quicker fashion, right? But if you want to do things algebraically, then you can totally solve it as a proportion, and that works too. All right, I way over talked that. So that's how you can do that problem. On your homework though, you'll be, like I said, you'll be given graphs and stuff like that. So you can just do it that quick, easy way if you want to. All right, you guys, I hope you feel pretty good about those story problems and that you are successful on your homework assignment. All right, see you soon.